Unix and Linux, two stalwarts in the domain of operating systems, have long been subject of comparisons and contrasts. This video delves deep into the origins, licensing models, kernel architectures, development paradigms, command line environments, file system structures, system initialization, and user interfaces to unravel the intricate tapestry that distinguishes Unix and Linux. And now, let's give it a start. Unix, conceived in the late 1960s at Bell Labs, emerged as a proprietary system catering to the specific needs of academic and research institutions. Its roots lie in the work of visionaries like Ken Thompson and Dennis Ritchie, who sought to create an efficient and powerful computing environment. Contrary, Linux, born in 1991 through the efforts of Linux stalwarts, was a rebellion against the proprietary model. Linus' decision to realize Linux under an open-source license laid the foundation of the paradigm shift in the operating system landscape. One of the foundational differences between Unix and Linux lies in the licensing model. Unix adheres to a traditional commercial license approach where users typically obtain the operating system through licensing agreements with major vendors such as IBM and Sun Microsystems. In this model, access to the source code and modifications rights are often restricted. On the other hand, Linux embodies the principles of the open source movement. Governed by licenses such as the GNU General Public License, Linux allows users not only to view and modify the source code, but also to distribute their versions freely. This fundamental shift towards openness has been a hallmark of Linux success. The kernel, often considered the heart of an operating system, reveals another layer of distinction between Unix and Linux. Unix, with its diverse variants like systemv and BSD, may exhibit different kernel architectures across implementations. For example, systemv and BSD Unix have distinctive kernel designs. In contrast, Linux boasts an independent kernel developed by Linux stalwarts and the open source community. While Linux follows Unix design principles, it does not have a direct lineage to any specific Unix versions. This autonomy has allowed Linux to evolve independently, incorporating features and optimizations driven by the open source community. The development paradigm of Unix and Linux reflect broader philosophical differences. Unix often follows a centralized development model where specific vendors control the development process and updates are channeled through official vendor channels. The pace of updates and the introduction of new features are, to a large extent, dictated by the vendor's roadmap. In contrast, Linux thrives on a distributed community-driven model. Developers from around the world collaborate on the Linux kernel and other components, leading to a more dynamic and adaptive development process. This approach results in frequent updates, quick bug fixes, and a rapid evolution of features, making Linux an agile and responsive operating system. For command line enthusiasts, the differences between Unix and Linux are apparent in their command line environments. Unix may showcase variants in command line utilities and shells across versions. For instance, different Unix variants may have different default shells such as Bourne shell, C shell, or Korn shell. This diversity can lead to inconsistencies for users customized to a specific shell. In contrast, Linux adheres to POSIX standards, ensuring a consistent command line experience across distributions. Bash has become the de facto standard shell in the Linux world, providing a powerful and uniform command line interface. This adherence to standards contributes to the portability of shell scripts and commands across different Linux distributions. The organization of file systems offers another lens through which we can discern the differences between Unix and Linux. Unix, with its various implementations, may present different file system hierarchies. Each Unix variant may adopt its own conversions, leading to a potential confusion of users transitioning between different Unix environments. In contrast, Linux adheres to the File System Hierarchy Standard (FHS), a set of guidelines that define the directory structure and organization of files in a Linux system. This standardization ensures consistency across different Linux distributions. Users familiar with one Linux distribution can navigate the file system of another with confidence, contributing to a more seamless experience. The process of system initialization is a crucial aspect of any operating system, reveals further distinctions between Unix and Linux. Unix may employ different initialization systems such as system vinit or bsd init, depending on the specific variant. These initialization systems dictate how the system boots, starts services, and initialize various components. The variability of initialization systems across Unix versions can pose challenges for users transitioning between different implementations. Linux, in contrast, exhibits a spectrum of initialization models. The traditional system vinit has been a staple for many years, but in recent times systemd has gained prevalence. Systemd is a modern initialization system that aims to improve system boot times, enhance service management, and provide better integration with other components. The choice of initialization systems can vary between Linux distributions, reflecting the flexibility and adaptability inherent in the Linux ecosystem. The evolution of user interfaces serves as a visual testament to the differences between Unix and Linux. Unix may showcase different graphical user interfaces, often varying between versions and implementations. The diversity of Unix GUIs can be attributed to the decentralized nature of Unix development, where different vendors and communities contribute to the user interface design. This can result in a lack of uniformity and consistency for user transitioning between different Unix environments. In contrast, Linux offers a plethora of desktop environments, each with its own unique look, feel, and features. Common desktop environments are, for example, GNOME, KDE Plasma, Cinnamon, and XFCE, among others. This variety allows Linux users to choose an interface that suits their preferences and workflow. The flexibility to switch between desktop environments is a distinctive feature of the Linux ecosystem, providing users with a customizable and personalized computer experience. In conclusion, the distinctions between Unix and Linux are multifaceted, spanning their origins, licensing models, kernel architectures, development paradigms, command line environments, file system structures, system initialization, and user interfaces. Unix, rooted in proprietary traditions, contrasts with the openness, collaboration, and adaptability that defines Linux. Each operating system has its strength and weakness, and the choice between them depends on a specific user case, preferences, and requirements. As technology continues to evolve, Unix and Linux will continue to shape the landscape of operating systems, each contributing to the rich tapestry of computing. This video acknowledges the contributions of the Unix and Linux communities, developers, and pioneers who have played pivotal roles in the evolution of these operating systems. And what are you? Team Unix or Team Linux? Why don't you write that in the comments? I'm already curious. Thank you for the kind attention. If you liked this video, I'd be happy to receive a free channel subscription, a thumbs up, and if you activate the bell, you'll be informed immediately when I publish something new. We both get something out of it. Take care, ladies and gentlemen. See you next time. Peace.